Have you ever wondered how an AI figures out a problem when it has absolutely no hints? I mean, think about a navigation system in a brand new city. It has a map, sure, but it has zero clues about traffic or road closures. That's the whole idea behind uninformed search. It's how AI starts solving problems when it's literally working in the dark. So let's pull back the curtain and see how it's done.
Right. Think about it like this. Your GPS is trying to get you to a new spot across town. It can see all the possible roads, but it has no idea which ones are packed with rush hour traffic or which ones have a massive pothole. To the AI, at first, every single road looks exactly the same. So how does it even begin to choose a path? That is the fundamental problem we are tackling today.
So here's our game plan. First, we're going to figure out what it even means to search in the dark. Then we'll meet our three different problem-solving AIs, the Cautious Explorer, the Deep Diver, and the Smartest Route Finder. And finally, we'll throw them into a final showdown to see which one is the right tool for the job.
Okay, let's dive right in with the basics. What are we really talking about when we say an AI is searching in the dark? This is the key right here. An uninformed or blind search literally means the algorithm only knows three things: where it's starting, what moves it's allowed to make, and what the goal looks like. That's it. It's kind of like playing that hot and cold game, except nobody ever tells you if you're getting warmer. Every single step is just a shot in the dark. So how on earth does an AI keep track of all these different possibilities without getting lost? Well, it builds a kind of virtual map in its head, and we call this map a search tree. You can think of it as its master plan for exploring every single option it has. And this search tree is actually pretty simple. You start at the very top, at the root. That's your starting point. From there, every possible move you can make creates a branch. Each of those branches leads to a new spot, a new state, which we call a node. And our whole mission is just to navigate this tree to find that one special node that is our goal. So, now we've got our map, but we need a strategy to explore it, right? So let's meet our first personality, the Cautious Explorer. Its official name is Breath's First Search, or just BFS for short. You got to think of BFS as being incredibly careful. It absolutely refuses to dive deep down any single path. Instead, it explores its world in these expanding ripples. It checks every single location that's just one step away. And only after it's mapped out its entire immediate neighborhood does it even think about taking another step out to the next level. So the process looks like this. You start at the root. Then you look at every single node that's one step away. Then, and only then, do you look at all the nodes 2 steps away, and so on. It just expands outward in these perfect clean circles until, bam, it lands on the goal. Now, this super cautious approach gives BFS some really powerful guarantees. For one, it's complete, which means if a solution exists, BFS is guaranteed to find it. It just can't miss it. It's also optimal, but only if every step costs the same. Since it always finds a goal that's 2 steps away before even looking at goals 3 steps away, you know you're getting the shortest path. The big downside? Oh man, checking every option at every level can take up a ton of memory. Okay, so if BFS is our cautious planner, what's its polar opposite? Well, meet Depth First Search, or DFS. This one is no cautious explorer. Oh no, this is an adventurous deep diver, and it's always in a race to the finish line. DFS has a total one-track mind. It picks a direction and just goes. It dives deeper and deeper and deeper down one single path, ignoring everything else around it. It only stops when it either finds the goal or smacks into a dead end. Only then does it backtrack, just a tiny bit, to try the next path over. Its strategy is aggressive, it's simple. Pick a path and go. Follow it all the way down. If you hit a wall, no worries. Just backtrack one step and try the next turn you could have taken. This deep and narrow approach can be incredibly fast if you get lucky and pick the right path early on. But, and this is a really big but, here's the catch. Look at this profile. DFS is not complete. What does that mean? It can actually get stuck in an infinitely long path and never ever find the solution that was waiting on another branch. It's also not optimal, not at all. It might find a super long roundabout way to the goal and completely miss a much shorter path that was right near the start. So we've got the cautious BFS and the risky DFS. But you might have noticed they kind of share a flaw. They both assume every single step is equal. But what happens in the real world, where some routes are way harder or longer than others? And this is the crucial point, right? Let's go back to our GPS. A route with 3 short city blocks is way better than a route with 2 10-mile highway stretches, isn't it? Well, BFS would pick the two-step path, even if it's way longer. It only counts the number of turns, not the actual distance. We need something a little smarter. And that's where Uniform Cost Search, or UCS, makes its grand entrance. UCS is the efficiency expert. It couldn't care less how many steps a path has. The only thing it cares about is the total cost to get there. UCS works kind of like a smarter version of BFS. Instead of expanding in those perfect little ripples, it always expands the path that has the lowest total cost so far. Imagine it keeps a to-do list of places to explore, but that list is always sorted from cheapest to most expensive. It just always picks the cheapest option off the top. This guarantees that the first time it finds the goal, it will have found the absolute most efficient route, period. Okay, we have met our 3 contenders. We've got the cautious explorer, the deep diver, and the efficiency expert. So let's put them all side by side and see how they really stack up against each other. The huge difference between BFS and DFS really just comes down to how they remember things. BFS uses a queue, like a line at the store. First one in is the first one out. This forces it to check all the old options before the new, deeper ones. DFS uses a stack, like a stack of plates. The last one you put on top is the first one you take off. This makes it always grab the newest, deepest option first. It's that one little difference that creates their totally opposite behaviors. And this table here lays it all out perfectly. Do you need to guarantee you'll find a solution? Then you have to avoid DFS. Do you need the absolute cheapest, most efficient path possible? Then UCS is your champion. And if all the steps are equal and you just want the path with the fewest turns, BFS is your guy. DFS really only makes sense when you have very little memory and you're okay with maybe finding a less than perfect solution. So what's the big takeaway here? It's that there is no single silver bullet. There's no one best algorithm. The right choice completely depends on the problem you're trying to solve. Are you in a maze? Are you solving a puzzle? Or are you trying to find the cheapest flight? Each one of those might need a different tool from our toolbox. And that leaves us with one final and I think fascinating question. All 3 of these strategies, they're really just stumbling around in the dark. I mean, they're powerful, but they're not very efficient. So what do you think would happen if we could give our AI a little hint, a sense of direction, a clue? Well, that opens up a whole new world of what we call informed search, where the AI isn't just searching blind, it's searching with a purpose. But that's a story for another explainer.